Hey guys, it's Bill from Linden, Tennessee. I got a lot done this weekend. I'm pretty happy with my progress. I got the wiring about 90% done. I got my coolant system all finished. I got a lot to talk about, so hopefully I can remember everything. Let's start with the coolant system first. So whenever I get on this thing, when it's finished, whenever I get on it to go there, I'm going to have two buttons. I'm going to have one button to push that'll sort of arm the 12-volt system, I guess you'd say. Think of it like an accessory, like you turn your key forward, sort of one click so you can listen to your radio or whatever. And then if you turn the key forward again, that would be sort of the run position. That's the position that it would be in if your engine was running. So I'm going to have one button that's sort of for the accessory, and then I'll have another button that will start the controller and make it so the thing will go. And whenever I do the run button and the controller starts up, I'll have it so that the water pump is on. So anytime the controller is on, the water pump is circulating water through the system to keep it cool. On the back of the controller, you can just barely see it in there if you know what you're looking for. There's a little thermostatic switch that's 65 degrees Celsius. So if the controller were to get up to 65 degrees Celsius, this fan, there's a little electric fan in there, it's hot when the water pump is running. So if that 65 degrees thermal switch trips, then the fan will come on and hopefully cool everything down. So that's how that works. So the pump here will grab coolant from the reservoir. I've got a little clear tube right there, sort of. It's going to be kind of like a visual, identification that there's coolant in the system without actually having to lift the hood and take the cap off of the reservoir. So it'll come down through there, it'll go through that tube down here, put on there, oops, and it'll come up underneath through here, go over and up into the chill plate behind the controller. It'll come back down through the other tube, and it'll come back up over here. It'll wind around, go down, go through the coolant. It's a transmission cooler from Summit Racing. You'd put it on like an automatic transmission for towing or whatever, but I'm just using it to cool the coolant, obviously. Then it'll come back, it'll do all of its cooling things, come back up through that there hose and go into the top of this reservoir on the side, and then in the middle there's a little crossover pipe. So that's going to be the flow of the coolant. Now I had originally thought about taking, instead of having this come all the way around like this, which looks kind of weird, I was just going to have a tube that just jumps between those two, kind of like on the other side. But the problem with that is, if you did that, the coolant would come up in here, but if there's no sort of breather, I guess you'd say, or some sort of a tube between the two at the top, the coolant would come up to the level of that crossover and then just cross over. It would never actually fill up here. You'd end up with an airlock. So I put this fitting up there high, so now the coolant will come in high and it'll just sort of drain down and cross over. And I don't think I'll end up with an airlock. I'm not 100% sure about that, but more sure that there won't be an airlock when it's like this than if I didn't do it like this. So anyway, but either way, there won't be an airlock on this side, so this side will fill up with coolant one way or the other, and that'll be plenty of circulation. So that worked out really nice. And yeah, the coolant can, the catch can turned out really great. I'm real pleased with how that came out, and it's nice and solid in there. These are two little mounting bolts from the original Cub Cadet. I think one of them had like a ignition, the regulator, the voltage regulator, I think that was on there or something, I don't remember, but just sort of reused those two holes. So that turned out really great. And then as for wiring, last video I had all this stuff all ripped out of here because I needed to get access in here, because I needed to run wires from the pump, from the coolant fan, and then also this relay, my main contactor. And also I have got a some wires going up there that'll be for a fog light, or maybe just a 12-volt accessory output or something. It'll be switched. It'll just be a switched 12-volt. You can do with it whatever you want to. Probably like, I don't know, up to 10 or 15 amps, something like that. So you couldn't run like a, you know, big inverter or anything. It'd be kind of like a cigarette lighter. Anything you can run off a cigarette lighter, that'll run off of it. And so yeah, so I had to get behind there and run all that, and had to make all my wires and little connectors. And then the main wiring harness, sort of, you can't see down there, it's dark, but it goes along underneath there, comes out just underneath the controller in here, and then sort of branches off, and some of it comes up this way. This wire right here is actually the 48 volts that goes to the shunt, and that's what runs the display. I'll show you that here in a minute. So that's what that's for. And this is my contactor for, I'm going to call it power takeoff, because this is my power takeoff. It's an electronic power takeoff. So I'll have a switch that will sort of arm the system. I will get into more detail with that once it's wired in. It's not wired in at the moment. Suffice to say, this is the contactor for that. And there will be a hot lead coming over from the battery positive. It'll come up to here, and then the contactor will be there, and then this will come out, and it'll go to my power takeoff outputs. But like I say, I'll talk more about that later. And then so where that hot lead comes in, I'll come from here and I'll jump over to this top circuit this top fuse here, and then so that's hot at all times, so that's going to power my display, and then it'll also power this orange one here. It'll power the DC-DC converter, and then when I have my charger mounted in here, then that's where the charger will come in also. So all three of those things are sort of hot at all times with 48 volts. This bottom one, that'll come from the other side of this contactor to here, and then from here it'll go to the power takeoff. So those power takeoffs will have a fuse protection also. And then this is just the 48 volt negative post. So this goes to the controller. This also goes to the DC-DC, and then the charger will tap into that as well. So that's how that is. And then if we follow the wires again, they go down underneath here, and then they come up right here, where again they branch off. Some of them go to the fuse panel that's over here. So I've got fuse protection for any 12 volt thing, and yeah, so the fan and the water pump and contactors and stuff, they'll get fused 12 volts from here. And then the other half of that circuit, so the negative side of those devices, will come up through this wiring harness, through these connectors here, and then they'll just go up to the switches. You know, so whenever you flip the switch up to turn the fog light on, it's just going to provide ground. It's going to provide ground for that, and then that's how that will work. These little connectors are kind of cool. They're just little 16-pin connectors I picked up off of Amazon. And that's what I searched for, just 16-pin connector, and it was like, I don't know, $5 or $8 or something like that. So I'm like, well, I might as well get 2 of them. And then they showed up at my door. It turned out that $5 or $8 was a pack of 5, so I ended up with 10 of them. So that's kind of, I'd like to say that's the first time I've done that, but it's not. So I sent 5 of them back. But anyway, so those worked out really good. I ended up with 2 extra holes, which is nice, for anything that I may have forgot, which I may have. I can use that other hole for that. And yeah, so that's that. And then this is my the contactor for the winch. These wires here, they come from the winch motor, and then they'll go onto these 2 top posts here. This is the 12 volts going from the battery, and this is just the 12 volt ground right here, and it literally just goes to the chassis ground. And then these 2 purple wires, they'll go up to a switch, so it'll be, you know, in and out for the winch. And what else? Oh, and then, so yeah, so this is the 48 volts like I was saying earlier. This is the 48 volts that's coming into the DC-DC converter up through here, up into that connector. The DC-DC has a this wire here on the end. Whenever you give that 48 volts, it turns the DC-DC on. So that's my alternator. So it forms the function of the alternator, like in your car. And whenever it's on, then the power comes from it through these wires. It grounds to the chassis here, and then it goes through a little 50 amp fuse right there. And then this will jump from here up to this positive post, and then yeah, and that's it. That's the end of that, because this goes back down to the battery. So that's the path of that power. And yeah, that's how that is. And then these, like I say, these are my winch ones. I got to figure out a nice looking way to route those. I might end up routing them from here and then come up and then put like a little clamp here or something. That's probably what I'll end up doing. But I got to come up with a nice way to make that look good. And then what else? Oh, so the wires come across here. Then this black wire, this goes up to my display. This gray wire here goes up to sort of a diagnostic display that's for the Curtis motor controller. And then there's also another display over there. That's my 12 volts. It just when I flip the power button, the 12 volt display will come on, and that's how I'll know that the system is armed, I guess you'd say. Yeah, and then this wire right here, the one that's got some corrugated plastic on it, that goes across, comes out right here, and it will ultimately go to the throttle, my electronic throttle, and that's what that'll be for. Now, as far as switches up here, I'm going to have, let's pull this off so we can see it better. So I'm going to have just push button switches for my accessories. Key switch ignition is what they call it in the wiring diagram, but that's just what I was saying. That's like the first position on your key in your car, and that'll give power to the DC-DC converter and give power to the PTO relay. Oh, apparently this camera only records for so long. So that's the accessory, and the next one's going to be a run. That'll make it so that I can go. Then over here, this is where all my PTO controls will be. There'll be a PTO arm. Then there'll be I got a little rheostat, sort of to ramp the power to a motor up slowly. And then there'll be a second switch up here that'll give full power, sort of bypass that it'll turn that contactor on that we were talking about earlier. And then there'll be a little light for the power takeoff. Over on this side, I'll have a switch up here for the fog lights. There'll be a switch right here for the winch. Then my forward and reverse will be right here. And also, there's going to be, I have the option of having, they call it eco, like economize switch. Like if you were in a car, you would do with that is you would set the controller so it doesn't give full amperage and it has more regen, and it would basically just be you would flip that switch if you wanted to conserve your battery. It's a little bit silly, really, because all you got to do is just drive a little more conservatively. It's the same thing, but it electronically limits you for power. I may or may not use that. I'm not sure what the utility of having that in this little tractor would be. I don't know. This switch right here, it toggles through the different readouts on the maintenance display there. And then this, of course, is my my display for my 48 volt battery. It's kind of a cool little dude. Shows you your state of charge, shows you how many amp hours are in your battery, shows currently how many watts are being used by the system. And whenever you have the light on, it's actually fine-tuned enough that it shows that it pulls 0.01 amps, 0.6 watts. It's kind of interesting. And I have that on right now because I'm kind of running an experiment, because this is actually pulling power out of the battery. Now, you wouldn't think it's pulling very much. Well, it's not pulling very much, but it does pull some. And what I want to do is I want to watch this voltage. My pack voltage right now is 57. I want to watch that over the next couple of days and see how fast it drains. Earlier I had this display on the battery, and this is just a really bright blue voltmeter, but man, this thing sucks some power. Like it would drop about 1/10 of a volt in 24 hours. And I mean, it doesn't really sound like a whole lot, but you know, if you have this thing parked up for a week, you know, that's a 24, you know, that's a 1/4 of a volt. That's actually a lot of energy. But anyway, so that is what that is. Yeah, I don't know. I think that's it. I think I've covered everything. I don't know. It's been a pretty busy week. I'm really happy with how this came along, and we're getting pretty close. So, all right. Thanks for watching.